Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 280, and today is our lesson number 74. Let's turn to page number 280, problem number 58. Problem number 58 on page 280, the second problem there. The problem is already on the blackboard. It says, what is the tens digit of a positive integer x? Let's first understand what they mean by tens digits. For example, 354.67. This is your tens digits that you're talking about. I don't know why they're using plural. It should just be 10 digit. It's a tens, unless they meant to put apostrophe. I don't know. 10 digit. This is the 10 digit. This is the 100 digit, obviously. 100 digit. This is the 1000 digit, and this is called tenth digit with the th, tenth digit. And here is your 100th digit. Make sure you pay attention to these things in the exam for questions like this, whether they're looking for 10 digit or whether they're looking for 10th digit. Here they're looking for 10 digit, and we are told that, and it's a positive integer, some integer positive integer x, we are told that when x is divided by 100, the remainder is 30. Well, if x is divided by 100, the remainder is 30, well, that means that x could be 130. 130 divided by 100 will have a remainder of 30. It could be 230, it could be 330, it could be 730, it could be 1030. All of these numbers, when you divide by 100, will have a remainder of 3. So which one is it? What's the value of x? They're not asking us for what is the value of x, they're asking us what is the 10 digit of x. It doesn't matter what value of x is. The point is, because when you divide it by 100, it has a remainder of 30, it will always have, in the 10 digit, it will always have 3. 10 digit will always be 3. There we go, we are able to answer the question. The question was, what is the 10 digit? And the answer is 3. So the first statement is enough. The first statement by itself does the job. AD, BCE. AD, BCE. Because the first statement by itself is enough, the answer cannot be B, C, or E. It has to be either A or a D. If you still do not know what I just did here, A, D, B, C, E, make sure you watch this introduction. Just type in GMAT data sufficiency intro and watch that video. Let's look at second statement. Second statement says, when x is divided by 110, the remainder is, again 30. The remainder is 30. Well, now since we are dividing by 110, x could be 140. 140 divided by 110 will have a remainder of 30. In which case, the tens digit would be 4. Or if you were to add 110 to this thing, 140 plus 110 is 250. 250 divided by 110 will go 2 times, which will be 220, and the remainder of 30. You see, the remainder is still 30, but the tens digit is different. Or it could be, let's go another 110. If you add another 11 to 25, is 36. 360. 360 divided by 110 will have a remainder of 30, because 110 times 3 will be 330, and the remainder of 30. Now the unit digit is 6. We can stop, but I'm going to keep on going for a couple of more times. Or we can have another one. Let's add another 110 to it. It will be 470. 470, if you were to divide by 110, 470 divided by 110, well, 440 would have been 4 times, and we would have a remainder of 3. But now the unit digit is 7. So which one is it? The question is, what is the unit digit? Oh, sorry, what is the tens digit? Which one is it? The 10 digit keeps changing. The tens digit keeps changing depending on what x is. And since we do not know what x exactly is, obviously, if you knew what what the exact value of x is, the problem will cease to exist, because there will be no point in asking the bloody question, what's the tens digit? We'll be able to see immediately what it is. Since we don't know the x, we can't really tell what the tens digit is. It could be 4, 5, 3, 6, it could be anything. But of course, we know that from the first statement, because the statements are always consistent, it has a tens digit of 3. If we were to keep on going, eventually we will see the 3, and that's the one anyway. Here, second statement by itself does not do the job. Second statement by itself does not do the job, and therefore the answer is A. Answer is A. I wonder what would happen one more time. If you were to add 11 to it again, it will be 58. Ah, there you go. 58, 580. 580. Oh no, that's not a 3 digit. We need a 3 there. But it will keep repeating 4, 5, 6, 7, 8, it's going to be 9, and it's going to keep on going, and eventually you will have a 3 there, which is what was in the first statement. But anyway, the answer here is A. The second statement does not tell us what the unit digit is for sure. Unit digit could be anything. The first statement does tell us for sure that the unit digit is 3. Oh, not the unit digit, sorry, I meant to say tens digit. Let's do the next problem. Problem number 59. Problem number 59. We have $125. We have $125 in $5 bills and $20 bills. Question simply is, how much is F? How much is F? F is, I'm using F here, letter F as, we think let F be the number of $5 bills. F for 5. And let T be the number of $20 bills. So based on those symbols, based on that terminology, the question simply is, what is F? In other words, they want to find out how many $5 bills we have if we have $125. Let's see what the problem says. This problem, by the way, this problem is very similar to problem number 57, which we did on day number 72. On day 72, we did this problem number 57, and if you have not watched problem number 57 on day 72, make sure you watch this problem. Obviously, you're watching it right now, and then watch the problem number 57 back to back and compare. You will see that they are very similar. The only difference is that in problem number 57, they were talking about gift certificates, and if I remember correctly, as a matter of fact, I can just look it up here. Problem number 57, we had gift certificates of $10 and $50. Listen very carefully. We had the gift certificates of $10 and $50. You can think of these gift certificates as dollar bills. So in that problem, we had $10 bills and we had $50 bills, and the total amount of money we had was $460. You see how similar they are? Here we have $5 bills. Here we have $5 bills and $20 bills, and the total amount that we have is $125. In problem number 57, we had $10 bills and we had $50 bills, and the total amount of money we had was $460. And they were asking the same question. They were asking how many total bills we have. They were not asking how many of a particular kind we had, but it's a very similar question. Let's continue. I thought you might like to know that. Let's continue. I need a room. I need a lot of room, so I'm going to erase everything and I'm going to start the work. Because if I were to start here, we won't have the room. Or should we do it over there? Let's do it over statement 1 over here. Let's do statement 1 over here. The statement 1 tells us, number 59, the statement 1 tells us that we have fewer than 5 bills worth $5 each. And $5 bills is what we're calling F. $5 bills is what we're calling F, and we are told that F is less than 5. So here is our F, and here is our T. Let's see what happens, okay? Since we have fewer than 5, I'm going to pretend that we have 4. If we have 4 $5 bills, that's $20. Okay, listen carefully. That's $20. And since we have a total of $125, if we did in fact have 4 $5 bills, that's $20. And since we have a total of $125, we are left with $105. And since T represents the number of $20 bills, that should say 20. I know I'm no good at spelling, but this is too much. Since T represents the number of $20 bills, 105, if we were to divide it by 20, it does not work. It does not work. 105 does not divide evenly into 20. So that's not possible. Now, since we are told that we have fewer than 5 $20 bills and the 4 did not work, let's try 3. Now 3 times 5 is 15. We have a total of $125 bills. That leaves us with 110. 110 divided by 20, that does not work. We have to divide by 20 because that represents the number of $20 bills. I'm trying to figure out how many $20 bills we have. We couldn't possibly have $110 left. In other words, we couldn't possibly have only 3 $5 bills, because if we had only 3 $5 bills and if we had a total of $125, we would have been left with $110. And you can't have $110 and $20 bills. Perhaps we have 2 $5 bills. 2 $5 bills makes $10. Total of $125. Now we have $115 left. $115, we can't possibly have $115 left in $20 bills. You can't have $115 in $20 bills. Now you do realize that I did say it. In all of my video, I go at a very leisurely pace. Because we're not in a hurry. We're just here to learn and we're just here to enjoy. That's the way I look at it. Do you understand? Obviously, I'm doing it because I'm getting something out of it. We're not here in a rush. Just take it easy, okay? So that doesn't work. Perhaps we have only 1 $5 bill. If we had only 1 $5 bills, I shouldn't say bill. If we had only 1 $5 bill, well, 1 $5 bill is just $5. We have a total of $125, which means we must have $120 left over. $120 in $20 bills. Aha! That's 6 of them. By golly, that's it. That works. That is the only possible scenario. That is the only possible explanation that is there. And the question was, how many $5 bills we have? We couldn't possibly have, given the fact, how many $5 bills we have, given the fact that we are told that we have fewer than 5 $5 bills. If we have fewer than 5 $5 bills, and the total amount of money that we have is $125, then the only possible scenario is when you have only 1 $5 bills. All the other scenarios do not work. We can't have 4 $5 bills, we cannot have 3 $5 bills, we cannot have 2 $5 bills, because the remaining amount will not go evenly into 20. We must have only 1 $5 bill, and we must have 6 $20 bills, making it a grand total of $125. Voila, what do you know? This was an interesting question. So the first statement does work. I erased the first statement, but the first statement does work. First statement does the job. even though it does not look like on the surface that it has enough information to answer the question, it actually does. So the first statement works, which means we can put down our AD, BCE somewhere. AD, BCE, and since the first statement by itself works, answer cannot be B, C, or E. It has to be either A or a D. Let's look at second statement, shall we? Let's look at second statement. Where can we do second statement without erasing anything? Without erase this part. Let's do second statement here. Let's do second statement at the bottom here. The second statement says that T is more than 5. Aha! It says we have more than 5 $20 bills. If we have more than 5 $20 bills, we must have 6 $20 bills. We must have 6 $20 bills because 6 times 20 is 120. We have only $125. 6 $20 bills plus 1 $5 bills makes a grand total of 125. The second statement is actually very simple because they tell you that we have more than 5 $20 bills. If we have more than 5 $20 bills, the very first number we should try is 6. We couldn't possibly have 7 because 7 times 20 is 140 already. We only have $125. So we must have 6 $20 bills and 1 $5 bills, just like what we found before. No difference. They should not conflict each other. They should not contradict each other. Whatever conclusion that we arrive at by using the information from one statement, it must always substantiate whatever conclusion that you will arrive at using the information in the second statement. They never contradict each other. If Michael turns out to be 85 years old from the first statement, Michael better not be 35-year-old based on the information from the second statement. And if that happens, something has gone awry, something has gone cuckoo, something has gone wrong. You must go back and check your work. They never contradict each other. If the first statement tells you that we have 6 $20 bills, the second statement bloody well also tell us that we have six $20 bills. Is that right? 6 $20 bills. That's right. That's it. We're done. I'm talking too much now. I'll see you tomorrow. Okay? Bye now.